looking at accretion and spreading, and looking at how disk mass and star mass scale together. So if you're interested in early disks, by K. Bale. We also have some stuff on, actually I've done the posters not quite in order so that we can see some of the things that are really tightly coupled. So again, stuff on the disk midplane, coupling dynamical and collisional evolution of dust, looking at dead zones in disks. So I thought we had a discussion of zombie planets earlier, and so these are dead zones, so they're zombie disks, I guess. We also have this other poster, which is a bit farther down from the first one, 715. Again, looking now at the disks some more, but now looking at the pebbles. And so these pebbles turning out to be very interesting. We can have pebbles in our disks by Ross. So this is more about ice condensation, though, and how you can get growth that way. So. And then, again, related to the same topic, is looking at implications for planetesimal growth out in the Kuiper Belt and trying to constrain, basically, these ideas of planet formation by looking at observational evidence in our own solar system for the size distribution of the Kuiper Belt. And I looked at this, and I'm not sure if this says that it works or it doesn't work. So you'll have to go talk to Andrew about that. And then right beside Andrew's poster is another poster on the same topic, basically looking at evolving growth for embryos in protostellar disks and how they will grow in traps that form. We saw these things where the pebbles get trapped as they're flowing it through. So. And then we have now moving on to thinking more about the actual planets that are forming in these disks and how they might be evolving. And so we have a nice work here on looking at the mass loss that's going on from hot Jupiter planet systems and looking at the effects of the UV radiation and the stellar winds. And this reminded me of when I was a student and we'd give seminars, and there was always one of the astronomy faculty would say, well, what would the effect of magnetic fields be? And of course, no one could ever answer those questions. And so then we have also radiative cooling and the convective interior. And so really looking at the whole process of cooling of these giant planets. That's on poster 713. And then someone thought, well, maybe we should look at the effects of magnetic fields. And so in fact, this does deal with how the atmospheres will behave in these exoplanets when there's magnetic fields and the fact that you can get plasmas developing in very localized areas, which actually causes additional cooling, which I think we're trying to get rid of cooling in giant planets, not make more of it. So maybe an issue there. And then finally, we can move on to the weather forecasts on planets that we are looking for. So I think it's great that we haven't quite found planets that we can really get really good handles on their weather, but of course we can start modeling that weather and think of what it is that we might be seeing in the future on those sorts of observations. And then if you want to know about if you want to do future stuff, well, you can look at really long-term thinking, and this is dealing with the very long-term habitability of exoplanet systems, so the very long-term weather forecasts and where life might continue to exist on these systems. And I think that's it. So that is the set of posters that we have available to us. There's one additional poster, poster 712, which wasn't in the program, but is now, which is by my postdoc, who would love to talk to you about her thesis research. So thank you.